Welcome to week
This
2.
meeting is being recorded.
Estimating. The textbook sections in rounding and estimating in our Moodle are still including chapter 1 for the nice textbook. So you can go there and look up chapter 1, section 3. And oh, that's 1.1. Go to 3. Chapter 1, section 3. There we go. And then see all of their good example problems and practice things and the videos that go with the examples. So all of that is free for you if it helps. The videos are a little skimpy. Some of these good content providers just had one video on rounding. But there's enough there that if something I'm doing this week is not quite enough, there's more to see. And our basic plan is the same. We have 3 ToDoodles that will stretch our brains in all the right ways. So I won't have to be boring and lecture at you. And then you have the My Open Math. And for the first time, we have worksheets. So when you click on this, then they are nice worksheets made by someone named David Lippman. And they're always one page that's sort of a summary review, and then the other page with some problems. The issue with these is they don't have answer sheets. So I have some answer sheets, but Moodle doesn't. So if you do them, then you need my help to make sure you did it right, which isn't hard. Most people just take their phone and take a picture of their scratch paper and email or text it to me, and then I get back to you. So the advantage of the My Open Math is that it grades it as you go, makes up different versions of a problem if you want. It's a quicker way to get that loop of feedback and say, yeah, I'm getting this, good for me. So same plan as always. I don't have a little chart yet, like I do for place value, where we talk about who thinks that the different ToDoodles were worthwhile or not when looked at on their own. Try again to look at about 1 ToDoodle a day to stay on track. But I will put a table like this at the end of the rounding and estimating also, and we can grade the ToDoodles. But for now, let's start. So I will open this and put the link in chat, like always. And then we can all join in and do stuff. For rounding and estimating, we only have 3. We might just get done with this whole topic today. Your warm-up for today is that there is a ski lift with the chairs equally spaced around the whole loop. And ski lifts sort of have a loop that they travel. They are numbered in order, starting at 1. And Kay went snowboarding. She got in chair 10 to go to the top. And exactly halfway to the top, she passed chair 100. So how many chairs are there in the ski lift? So drawing this, in case it's not clear already, then there's the loop of the ski lift. Right? So up here is where you get off at the top. And down here is where you get on at the bottom. There's chairs equally spaced all along this thing, going all the way up and all the way down. They have numbers, and she is here at number 10, going up. And right opposite her is number 100, going down. So how many different chairs are there on this ski lift machine?
Would this be considered like a division?
Talk to each other. Tell each other what you think might work.
How many shares are there? I got no idea. She. On the SKU list.
Hmm. 200 keeps coming to mind for some reason. I don't know if that's right, but
I haven't added it yet.
I'll just put it over here. I'm not quite sure how to fit it in until you tell me you're thinking, but 200 could be it.
It won't let me grab that the mouse to write it on the board. Again, I don't know. Someone has to write, but it sounds. I was gonna put 180. That was my top of my head.
It does have editing. You were thinking 180. How did
Yeah,
you
like
180?
no. I added how how many feet is it from when he started to the end? So it'll be like 100 feet.
I think I sort of see what you're saying, but we're not sure that there's spaced apart at any certain distance. If they were only a foot apart, that would be much too crowded. I would keep hitting the person in front of me with my skis. But you said there was 90, and it certainly seems true that between here and here, there's 90 of them, because we're counting from 10 to 100.
All right.
maybe 190.
Would be 190.
I was thinking 192. Because from the 10 to the 100, there's 90 in between. That means from the 100 to the other way around, there probably is 90. I don't know, maybe.
If there is 90 going the other way, that would
Yeah.
make sense because it said it was halfway.
Yeah.
Actually, yeah.
When we're starting at 10 and going to 100, that's 90 more of them. And that includes the 100, right? So it's not like we need 91, it's just 90. So I think the 180 seems right to me. That going all the way around the top to get back to where she is 90 of them. And then that means the mirror image on the other side is also 90. So 180 seems the right answer.
Look, yes.
But this one didn't come with an answer key, so I'm not sure that that's officially the right answer, but it makes sense to me.
Same here.
Okay, now on to our main topic. So rounding is about avoiding when we exaggerate. Sometimes our answers have fake accuracy, and the big culprit in this is division. Division is great at making these long decimals in our calculators. And they make the long decimals even if we don't know things with that much accuracy. So as 3 different little stories, imagine we have 100 of something and we're dividing it into 7 equal parts. So we're doing 100 divided by 7 in 3 different stories. If I do this on the calculator, I get a number that's a little bit more than 14. It's 14.285714, and it keeps going on and on. But let's think about 3 different stories where we might be doing that type of taking 100 and making 7 equal parts. In the first story, I'm getting ready for a birthday party with my kid. There's 100 candies and 7 party favor bags. So how many candies go in each bag? I would put 14 in each bag Am I going to chop up any candies and give them some little decimal part? No.
No.
And if I open the calculator and say, by the way, what is 14 times 7? That's 98 of them. So there's 2 left over. I'm just going to eat those 2, right? Woo, parent bonus. So I'm not going to try and chop them up so that the kids somehow get bits of candy. That would make a mess and be sticky. On the other hand, if I had a 100-inch board and I needed to cut it into 7 parts, I can cut more than to the nearest inch with a saw. I can probably cut about to the 1/10 of an inch. Just looking at a tape measure, that's about how accurate my sawing is. Do I really think I can aim to the nearest 100th of an inch? Not the way I saw, right? Maybe if I had some fancy mechanical laser saw, I could cut that well, but no, I don't. But just because of the tools I'm using, the 1/10 of an inch sounds like the right amount of accuracy, and I should round to that. Tangentially, if I wanted to do that, I want to round to the 2. How do I do that? How do I round to the 2? I have to look at the 8. And I'm wondering, is this more like 14.2 or is it more like 14.3? And think of it like money. If I have 28 cents, is that closer to saying that I have 20 cents? Or is that closer to saying I have 30 cents?
30.
30. So you've probably heard the rule that if you're rounding to 1 digit, look to the next digit to the right. If it's 5 or more, it makes this one go up from a 2 to a 3. Does that sound familiar from some older math class?
Yep.
So this would be 14.3 inches in this story. As my third story, if I am a pharmacist with a fancy electric scale that's good at measuring to the thousandths of a gram, and I have exactly 100 grams of medicine, and I need to make 7 doses for each day of the week, then I could count tenths, hundredths, thousandths. Where did I get that 6 from? It used to be a 5, but the 7 said go up to the next number because that 7 is 5 or more. So I get 286 on my pharmacy scale. So in all 3 of these stories, there's some real life situation, some type of goal or tool that's telling me how much accuracy is actually reasonable. Anything more than that, I'm sort of exaggerating. I don't really know things that well. I can't tell with my handsaw whether I'm doing 14.21 inches or 14.22 inches. So writing down an answer that had more than 1 decimal place would be claiming I have some amazing robotic precision that I don't. Everyone with me so far?
Yes.
Yeah.
So that's kind of real life, what happens. You look at what's happening in real life. What tools do you have? Is it reasonable to chop things into pieces or not? And then you round appropriately. But there is just
I have
a
one
general,
question.
sure.
On the last one, it's kind of confusing me a little bit because you said that the 6 used to be that 5 over there.
Yeah, so let me write it out. We had 14.2857, blah, blah, blah. So I want to round to that 3rd place, tenths, hundredths, thousandths. So I look at the next one over to the right, and is that 5 or more?
Yeah.
Yes.
So you
it
round that
makes
one to
this
6.
go up.
Okay. I gotcha.
For most people, it's easiest to think of money, right? Imagine that I had, just look at these numbers. If I had 57 cents, is that closer to 60 cents or 50 cents? It's closer to 60 cents.
Mm-hmm. Makes sense.
So, okay, but this is real life. And unfortunately, you might be asked to round just on a test where there's no context about what's happening. So the general rule is, I don't write it here, but I did, that you look at how many digits they gave you in the original problem and use that many. So in this case, if they just said 107, there's no decimal. So just don't put a decimal, round it to 14. And then the general rule continues, if you want, you can add one more decimal place, because sometimes just the physical act of making smaller piles does give you a little bit more accuracy. So 14.3 could also be acceptable. So use the same number of decimal places as the problem's initial numbers gave you, or one more. We'll do lots of examples. So rounding happens at the end of a math problem. We've gotten some answer. It has too many decimal points compared to what's a reasonable amount of accuracy for that situation. So we chop off some fake accuracy and keep just what's reasonable. Estimating is a very different thing. This is what happens at the start of a math problem, before we start the math. So as a story about estimating, we're trying to drive from Seattle to San Diego. I want to know about how much I'll spend on gas. And I simply don't have the right numbers. I don't know exactly what mileage my car will get, because that depends on the traffic and driving conditions. I don't know what the cost will be. I can look it up today on the internet, but this is a multiple day trip. I might have to buy gas 2 or 3 days, and that might change. So I can do my best. I can pick numbers that I think are as accurate as they can be, but my numbers will be guesses. And so estimating is something that will limit the accuracy of those initial numbers, just like your tool, the handsaw or the pharmacist scale. It will be a clue as to what kind of accuracy is reasonable when we get to the end. Unfortunately, a lot of math classes treat rounding and estimating as if they are the same. They just look at this mechanical process of, here is one digit, let's look one to the right. Is it 5 or more? If so, this goes up 1. And we'll call that rounding and estimating. But just be a nice educated person, know that they're different. The process might look the same, but rounding is at the end. We get an answer and we want to not lie. Estimating is at the beginning. We just don't know the numbers, so we have to make them up and do the best we can. Everyone with me so far?
Mm-hmm.
Yes.
Okay, your turn to do things. So the blue numbers are movable. Grab the blue numbers and put them in the right basket. Are they closer to 0 or 10?
I can't move mine.
Someone got it. 1 is closer to 0. Yep, try not to move the whole number line.
I'm sorry, it keeps moving the line. I'm trying
That's
not
okay.
to.
I can't grab it.
So some of these are easy. 9 is obviously much closer to one basket than the other. The one that we need to kind of debate is 5. What do we do with 5? It's right in the middle. How do we know which basket it goes to?
That one. 0.
It does go,
No, 0.
it actually doesn't go to 0.
Oh, wow.
It could. It's right in the middle. It's not like Mother Nature has some
But
preference.
it's considered a bigger number, right? So
But 5, yes, but somebody had to make a rule so that they could grade homework. And the standard, the convention is that 5 counts as a bigger number. 5 goes up.
So that's just like a general rule. 5
That's
goes
just the
up.
general rules. They had to make a decision. So there we go. 5 goes up. On the bottom, now we're not rounding to the nearest 1 or the nearest 10, but to the nearest 100. So this was to the nearest 10. Is it closer to 0 or 10? Now we're picking hundreds. Are these closer to 200 or 300? And somebody put 288 already there. Yes, it's a big thing. It's closer to 300. And again, the interesting one was 250. It's right in the middle. 50 is halfway between 0 and 100. 250 is halfway between 200 and 300. So kind of just by the laws of nature, there's not one that it belongs to, but just by the convention, the rules of math that somebody invented, 250 counts as a bigger number. Ready for the next page?
Yep.
Oh, okay. So, oh, here's that rule I said. The general rule is to round answers with the same accuracy as the initial numbers. But for now, let's do a story that has a rule that we're going to be house shopping. And house prices are often rounded to the nearest 1,000. People tend to say this is a $120,000 house or a $132,000 house. They don't say this house costs $132,000, 412. And the reason they do that is if you were to buy the house, then it's going to be off by about 1,000. By the time you pay the mortgage broker and the inspections and the licensing fees and all these other rigmaroles, then it's like you're off by 1,000 anyway. Does that make sense? So we have a movable green thing, and we're going to look at each number. Somebody grab it after this first one and move it. If we're rounding 5,000 in the 145,000, is it going to go up because of the 2 or stay the same?
Stay the same?
Yeah, the 2 is a small thing. It goes to the basket that's like 0. So when the 2 disappears, we don't have to do anything to compensate for that. All of these numbers we can just change to 0, and the price is closer to 145 than it would be to 146.
Okay, I gotcha.
Move the little frame to the next one. So is this going to be 336 or 337?
337.
336.
I hear both. Somebody-
336.
So it is the 6. 3 is not 5 or more. 3 is a small number, so it doesn't change the 6. Going back to here, 3 is over on this side, so it goes to 0 and doesn't change anything. Okay, move the little green frame.
Can't grab it. Jeez.
Grab it.
Me neither.
Let me see if I can make it be on top. Order, bring to front. Okay, see if that works better. Can you grab it now?
Yeah, I got it.
Okay, is that going to be 102,000 or 103,000?
102.
Yeah,
103.
102.
We're getting close. It's almost $500, but it's only $499. We're not quite to the middle. On this page, we're like right there, almost to the middle, but not quite. Okay, next row. Are we going to do 228 or 229?
229.
9.
29.
9. Yep, 9 is definitely 5 or more. It's a bigger one, so we're going to move the thing we're rounding up. $410 or 411?
411.
411.
411. And again, where the box is always just turns into zeros, right? We're getting rid of that. Okay, last one. What happens here?
Stays the same.
It stays the same. Everyone happy with all of those?
Mhm.
If I was really doing this on a test, I'd want to label my answers. They have dollar signs, so I should do that.
So
Okay.
you'd be correcting for that?
I'm not sure how the GED works. I'm not sure how the grading happens, but it's a good habit to get into just in case.
Okay.
So your homeworky part, think about this or talk about it with the people that are friends and family. Think about some of your accuracy tools. If you just heft something in your hand, then can you judge its weight? How much? 1 pound, 10 pounds, 1/10 of a pound? How good are you at judging weight with your hands? Or if you look at something across the room, maybe it's even a big room, can you say, I know how many feet that is away, or tens of feet, or tenths of feet? Or if you're jogging or running, how good are you at knowing speeds? Can you tell when you're on your bicycle what nearest mile per hour you're at? Or just if you're closer to 0 or 10 miles per hour? Or maybe you're very good at this and I'm going biking at 5.6 miles per hour. When you're using a ruler or tape measure, can you measure to the nearest foot or 10 feet or tenths of a foot? Or how about your thermostat? When you go into a room and you say, oh, this is about 76 degrees, or just it's somewhere like 70, more than 80. Well, maybe you're very good at temperatures. This feels like 76.5 to me. So we might have different answers to this based on our practical experience. I've worked with carpenters that could just look at something and know to the 1/10 of an inch how long it is if it's a small thing. And I can't do that, but they've worked with enough small things that needed to fit together that they were good at that. So think about this for your own accuracy.
Yes, yes. I know. Did you push it? Oh.
Questions about what this is?
No, it's not so far.
Okay, I'm going to stop the recording.